So you have an Ender 5 Plus 3D printer, and at this point you've come to realize it's not the quietest printer in the world. Well, in this video and one more follow-up video, I'm going to show you several different upgrades for this printer to quiet it down. In this video, I'm going to show you the simplest option, and that's upgrading to the Creality Silent board for the Ender 5 Plus. So what makes this board different than the one it comes with, and how exactly do you go about the upgrade, and in the end, what will be the results of this upgrade? Well, that's what I'm going to be showing you right here today on Kersey Fabrications. Let's go. So on this channel before, I've already covered doing a silent board upgrade on my regular Ender 5 3D printer. Now it's important to keep in mind that this main board is not that main board. The one in the regular Ender 5 is usually labeled 114 or 115. It's a much simpler board than the one you'll find in this printer. This is usually labeled V2.2. Now, where can you find this main board? Well, there's only one place right now that I would trust ordering that from, and that is from the Creality3dofficial.com. That is Creality's official website. I'm going to put it up right here, and it will be in the description. It's the only place that I know that I can guarantee that you're getting official hardware. Now, when you go to that page, you'll see that they offer this board in 3 different flavors. They'll offer it for the Ender 5 Plus, the CRX, and the CR10S. It's my understanding that all 3 of them are the same board, but if you want it to come pre-flashed for your printer, just like mine did, then you'll want to order it for your specific board. So what makes this board different than the one that comes with the stock printer? Well, there's only one main difference, and that's that it has different stepper drivers on here, the chips that actually control the signals to your stepper motors. Now, the ones that it come with are called TMC2208s as opposed to the A4988s that it came with. And the difference in noise level that these chips produce is night and day. The TMC2208 drivers are much more advanced. They produce a much better signal for these steppers, which results in less noise. Now, as I showed in some of the videos on my Ender 5, this also can result in nicer prints. And that's going to be one of the other things I'm looking at in this video. So what am I going to be testing? So first of all, noise level, obviously. I have a sound meter I'm going to be looking at. I also have an app on my phone that I'm hoping will show kind of the difference in spectrum between the different sounds that you're going to hear with this printer. As you may know, the sound that these usually produce is pretty high-pitched, which is much more annoying than like a low fan rumble. Now, just to see if we can expect any quality improvements in your prints, I'm also going to be printing a couple of test prints. I have this skull that I've already printed on the printer. I chose this one because it has a lot of smooth curves. If there's any improvement in the consistency of the print, you're going to see it on this test print. And I'm also doing a mechanical test. So I've got this Raspberry Pi box, which I can take a look at the quality of the walls and some of the internal components to see just how consistent we're getting in a mechanical design. So without further ado, let's go ahead and let me show you how to upgrade this printer. Now the first thing we're going to do, of course, when you start any modification to your electrical system, unplug it from the power. Next up, we can disconnect the power supply from the electronics. Now, if you haven't done this power supply mod that I showed you in my other video, then you don't have to do this step. You can simply make it where you can disconnect the rest of the components. You may want to unplug some of these depending on how much room you have to work. You're going to unplug your wiring from your different components, but if you've got room to work, you may not have to do that. Now, once you have those disconnected, we can then move on to removing the box. As I mentioned in my power supply video, I find that it's much easier to remove the entire box than to try to turn over the whole printer, which may cause you more problems by messing up your alignment or, different parts of the printer. Obviously, if you have any USB devices, disconnect those. as well as pull out any SD cards that may be in your printer. Now this can be flipped over fairly easily, and we can work from there. Now, for the sake of this video and for the ease of showing you how to do this, I have completely disconnected all of the wires from my power supply while I do this. You notice they're all back here. These are all the wires that you hooked up when you first got your printer. I went ahead and disconnected it. Now, whatever you want to do in terms of getting to these components easily, that's up to you. As you saw just a minute ago, I had it just tilted on its side. If that works for you, just do that. It'll save you a little bit of time. But make sure you have enough room to work. You don't want to get frustrated because your hands get tangled up or because you just can't get to what you need to. So I have all of these screws disconnected. We're going to now pull out the top. And notice this is plugged in right here. I'm going to unplug that, set that aside. Now when it comes to replacing this main board, you're going to have a lot of options, and there's not one right way to do this. Now, some of these are already labeled, so these have little labels that say X, Y, Z1, Z2, E. Those sort of things are already labeled, so these will be easy to put back. Now, some of these other components, though, can go in multiple places and they're not labeled. So you have some choices. You can look at the board, figure out where they're supposed to go, and then put little tabs on them if you want to. Or you could take different colored markers and mark the wires so that you can figure out where they're supposed to go. You could take pictures, however you want to do it. Again, there's really not a wrong way as long as you can keep up with where those wires came from to begin with. Obviously, we're just going to be taking all of the wires from this board, hooking them up to this board, and getting everything screwed back down. So here's how I'm going to do it. Again, if you do it this way, please be very careful. I'm going to show you what I feel is the best way to get everything hooked up without losing track of where they go. Again, this is my way of doing it. Choose which way makes the most sense to you. First of all, I'm going to pull off this one, which comes from the LCD screen. Then I'm going to go ahead, if you notice all these wires come this direction, depending on whether you have your power supply here, you may have more or less room in here. I have lots of room right now. I'm going to go ahead and pull the screws out of this board. Let me mention a little bit about grounding. Make sure that you're grounded to something. Make sure you're touching the metal chassis here. If you're doing this on carpet, that's not particularly a good thing because you could be developing static electricity. You're going to take precautions to try to ground yourself as much as possible. Hopefully this chassis, even disconnected from the wall, will provide enough grounding. So there are 4 screws in this board, and then it should come free. Now I'm just going to pull this board aside. Now I can take my new board, go ahead and get that placed in the correct location, and then screw down my new board. There we go, everything's tightened down. I'll take this LCD, put that right back where it came from, scoot that out of the way. Now what I can do, I can take these one at a time and just move them back to the new board, not forgetting where anything goes. Now, if you've never moved yours before, they could have hot glue on them still. If they have hot glue on them still, you're going to have to break that off either with some needle nose pliers or just by wiggling it, you're probably going to be able to get those off just like that. And then if you want to, you can go and pull off that hot glue or leave it on, whichever one you want. I'm going to come back to that one in a minute. Let's get these low-hanging ones down here. Now this one, notice there are 4 sets of pins here. It goes on the 3rd, counting this way, 1, 2, 3. And then there's just 1 set on the other side. It's going to go right there. Then I can start pulling these over. It goes on the bottom. And I'm just going to take these together, not losing track of where they go. Now, another thing I could do at this point to make this easier on myself is there is still a tie wrap here, which is keeping this a little bit too tight to work with. I can very carefully cut that tie wrap off. Now these things will not be so tight being held together. This fan, I'm going to go to the bottom one. And I'm going to just go ahead and pull these off because these are well labeled, like I mentioned, and that will get them out of my way. And I may not be doing these wires in the most efficient order, but do whatever makes sense to you. That fan goes here. Now the cooling fan for the components, which is on my lid, is going to go to this one right here next to this one that I just plugged in. I'm going to grab different flathead screwdriver here. Go ahead and loosen up the terminals that I'm going to need. Now what you're looking for, and I can't show you this very well, but as you're unscrewing these, the terminals are dropping down on this far side, leaving an opening for you to stick the wires through. So if you've never done that before, that's what you're looking for. As you unscrew these, terminals drop down here, and then as you tighten them back up, they will rise. And these two don't matter which side they go on. They are not polarized in any way. But I'm going to try to keep them on the same side. Make sure when you put these back in that you're pinching the wire and not pinching the sheathing of the wire, because obviously if you pinch the plastic of the wire, you're not going to get connectivity, and you're going to wonder why your hot end doesn't heat up. And then this one's your bed. Now this one does matter. Notice the black one is on this side, the red one is on this side, and on the board it is labeled minus and plus. These do need to be put back on the same side that they come off. There we go. Again, negative on this side, positive on this side. And these are arguably the most important wires that you're going to reconnect. These are the power wires that go to the main board. Again, polarity, very, very important here. Negative on this side, positive on this side, black and red. Otherwise, you're really going to give yourself a problem and probably blow up the board. There you go. Now with all of these, I just give them a gentle tug to make sure that they're seated correctly. Now I can come in with my motor wires. Again, pull off any plastic, any hot glue that's still on them. And then pay attention to these. This one's Y, so it goes here. This one should be X, so it goes right here. And then I have E. So this is the extruder. It goes into E0, which is the next one right here. Excuse me, not the next one, but the 1 second from the end. Then this one's Z1 and Z2. And these don't really matter which ones they go into, because these two are both split off of this one driver. I'm going to put Z2 on the bottom, Z1 on the top. Again, not really important. Now if I want, I can come in here. Let me grab some zip ties. Make sure I have everything hooked back up. Make sure there's nothing loose that I forgot to put back together. And I'm going to zip tie this back up the way I found it. I'm going to take this fan. Like I said, it goes to the top one here again. Don't put it in the one in the middle, because if you do, it will only cut on with your hot end, and that's a bad thing. Now let's button this back up and reinstall it. Alright, so I'm going to plug back in my SD card. I'm going to plug back in my USB. Now, of course, I don't have to do this right now. I'm just doing it because I want to. And now for the moment of truth, does it cut back on? Oh, you know what? It helps if you plug in the power. Alright, so now the power's plugged in. Now does it cut back on? I hear the BL touch. And Do we power up? Yes, we do. Everything is working like it should be. So now, next steps, let's go up top and get the printer set up. All right, so with the new board, we are back to square one, and we need to go through our leveling, Z offset, everything that we started out with on our brand new printer. So I go to the leveling menu, just like we did before. And this will go through its normal BL Touch leveling sequence. So you can already hear during this leveling sequence, much quieter than our old printer, we do not hear the movement of the printer. Obviously I do have another printer going here in the background, but you'd hear the motors of this one if it was going. Absolutely no motor squeal. And if you're familiar with the way that yours came, hopefully it came way off offset. So this is not the proper Z offset, obviously, and we're going to need to adjust it accordingly. Now make sure you have your hot end and your nozzle heated up for this. And then we are going to adjust our nozzle down until we are barely scraping. And I'll show you a trick that I have found on this printer that works for me. Can't promise it'll work for you. This is what I found. So if you go to right where it's scratching and then go one more where it is really hard to get out, I find that that is the proper Z offset for this printer. At least that works for me. You would think it was one up to where it moves freely, but for whatever reason, I always find that going one down where it feels too tight is the proper leveling on this printer for me. Now once you've done that, you can go through the four corners leveling first. All right, once you get all of that done, then we can go through the measured bed leveling to get the mesh. All right, now that we're all done here, it is time to go through our test prints. So I made it through a couple of test prints with the new board in, and so I got the first print off and I compared it to my before print, the one with the stock board, and I wasn't really happy with the sidewalls. I can't really tell you what it is. You probably won't even be able to see. The camera doesn't want to focus, but anyway, you probably wouldn't even be able to see the difference. It's kind of a sheen difference in the sidewall, so something didn't look quite right. Don't really know what it was. Really didn't notice anything while this was printing, but I wasn't standing nearby the whole time it was going. But when it came to do the skull print that I'm doing for a test print, that's when I noticed what was going on. So with this print, number one, when it was printing the raft, I had lots of clicking in the extruder. That was my first thing I really noticed. But as it got up a few layers, I noticed, well, the clicking seems to be going. Maybe it's just a low layer thing. But what I noticed once I finally got this to print correctly is that the infill is just really garbage. Which means that that clicking that I first heard and probably what I was seeing on my other print is under extrusion, because basically this board, since they put a TMC driver on the extruder as well, it probably doesn't have enough current to keep that extruder going. So unfortunately at this point what I need to do, I need to flip the printer over. Unfortunately I can't just move the box like I did last time, because I have to be able to get to it while it's powered up in order to adjust the potentiometers that are on each of those steppers. So that's what I'm going to do next. Got to flip this over, and I'll show you what to do if you have any of your stepper motors that are not driving the steppers correctly, particularly if you're getting any skipping or stuttering in those motors. All right, so I have my printer on its side here. Again, I had to do this so that I could get to the board while it's powered up. So what I'm needing to do, I need to check how much reference voltage is on each of these drivers. That's going to give me a good idea about how much power is going to be going to the stepper motors. So first of all, I've got my multimeter here on 20 volts and DC, of course. Then I'm going to stick my black lead, my ground lead, to one of the black wires here or on one of these. Actually, it needs to be here. Let's go ahead and put it here. There's my black lead. And then I'm going to see the little screws by each one of them. They're on the bottom or left side, whatever you want to say, there's a little screw that is by each one of these drivers. And be very careful not to touch anything but the screw. You could short something out on this board. I'm going to touch that. So this one's at 0.55. That's extremely low. That's my x-axis. This one's 0.72. That's going to be about average what you see on these. 0.83. That is my z-axis, so they already have that one turned up. And then E is back down to 0.73. And honestly, the extruder is actually going to need to be one of our highest voltages because that's actually doing more work than almost any of the other steppers here. So the Z is good there at 0.83 because it's driving 2 steppers. I'm going to kind of go off of that reference voltage, and actually to be safe, I'm going to take all of them up to that 0.8 because I just feel a lot bit better for the long term running them at that higher voltage. Now you don't have to. Any of these that are running good for you that you don't want to modify, you don't need to modify, but I'm going to do this as a preventative measure. And then later we'll check our steppers, make sure nothing's overheating. Again, this one's at 0.55. I'm going to grab a very small screwdriver. Again, make sure you're not touching anything but that screw. Let's turn to the right, see if that's the correct way. Just very, very small turns. Don't get in a hurry. If you turn this too much, you could blow up that driver there. So actually we need to go to the left to go up. So let's see where we're at now. 0.58. Also keep in mind there are other ways to do this. I could have attached some alligator clamps directly to this and measured as I went. Didn't have that set up right now, so this is what I'm using. There's a 0.7, we're getting close. 0.83 on the nose. Need to go up about that far on that one. 0.82, we're good there. This is the one that was already at 0.83. So now we just need to turn up that extruder. And we're going to test this. I'm actually not going to put the cover back on here yet because until I'm sure that this is enough current, I'm not actually going to button this up. And that's 0.87. 0.88. You know what? Just because I want some extra power there, I want to leave that there. We're going to check the temperatures of the steppers later, make sure we're not burning anything up, but I want to leave that at 0.88 for now. We're going to run those test prints again and see how it looks.
Tomorrow for sure.
So after much testing and a mostly finished skull here that I was working on as a test print, I think I've basically come up with the settings that I want to use here. I think these are going to be my final settings for this because I've spent a lot of time trying to figure this out and get the settings just right. One thing I've learned, if you set the voltages too high on our X and Y steppers, then you get more noise out of them. And still, if you're not setting this the voltage on this stepper, you're definitely going to get skipping still. So I'm going to set both of these around the 0.6, maybe a little bit above 0.6 mark. I'm going to leave this, I think basically what it came at, probably about the 1.2 I think is what this at. And I'm going to go all the way 1.4 on our stepper. So let's see where we are here. So here we are 0.61. This one we're at 0.56, so I'm going to take that one up just a little bit. 0.65, I'm okay with that. On this one, 0.83. Let's just take that up to a full 1. I think we'll be fine there. There you go, 0.991. That's exactly where we want to be. And on this one, I am currently at 0.32. I'm going to take that up a little bit more. I'm still getting just a little bit of skipping. 145. You know what? That's really a little bit higher than I think this is going to be rated at. I don't want to take this too high. I don't want to burn up these steppers, or I'm going to need more cooling on them. Although if I have the choice, I'm going to go higher than lower because I was still getting skipping. So there's a 139. I'm going to leave it right there. We're going to try there. That's going to be about as high as I can take this without feeling like I'm going to burn it up. I'm going to leave it right there. I'm going to turn this back on its side. I'm going to print that skull and box test print. We're going to see how they look. Here we have the side-by-side sound comparison of these two boards. I was originally going to do this in two segments, but decided this was a better way to present this data. So here we have on the left, we have the original board, the decibel meter showing anywhere from 60 to 65 decibels, averaging about 63. On the right, we have the silent board, averaging probably around 58, 59 decibels, peaking no more than 60. So we have about a 5 decibel difference, which doesn't sound like a lot, but when it comes to sound, can actually be considerably more. Now next up, I have an app on my phone that will show the spectrum of the two printers. So on the left, you have the original board, and that's showing some peaks, particularly around the 1100 hertz range. But even down into the lower frequencies, we're kind of seeing kind of a messier curve, where on the silent board on the right, that 1100 hertz has been really flattened out. And just in general, the curve itself is a lot flatter because mainly we're hearing just the fan noise. Now, what I'm going to do right here is, hearing is believing. So first up, this is the sound that the original board makes. And second up, here is the sound that the silent board makes. Now the difference in the two clips obviously is not the fan noise in the background, but that high-pitched sound that we get from the motors. You don't hear that on the silent board anymore. So now that we've heard the difference between the two boards, let's see if we can see a difference in the quality of our prints. So here we are with our two sets of test prints. The skull models were done to check the smoothness and overall layer consistency of the printer. And this one being the before and this one being the after the mod. I would be really hard pressed to tell you that there was anything different between these two prints. I wouldn't have known that there was any change done to the printer. There's really no quality difference underneath in terms of the layers. Once I got those extruder issues sorted out, I seem to have pretty much the same printer as before in terms of print quality. Looking at the mechanical models, again, same thing. Any flaw that was there in the model, I see in both of them. Probably a slicer issue, if anything. And again, the layer consistency between the two, pretty much identical. So while the mod does give us a quieter printer, it doesn't seem to buy us much more than that. This is purely for peace of mind if you're printing in an environment that you really need it to quiet down the printer. So, time for my final thoughts. So what are my final thoughts on replacing your stock board with a silent board? Well, first of all, this mod took me way longer than I expected it to, and I think from watching the video, the reason for that's pretty obvious. I had to go in and I had to tweak and fiddle with the stepper voltages in order to get this printer printing the way I expected it to from my previous experience with the stock board. Now, hopefully my experience in this video will help you not to have to go through all of that. If you are having printing issues with the board after you've tested it the way it came from the factory, hopefully you can use the voltages I came up with to get a more reliable printing experience on your printer. Now, while we're still talking about that, let me mention that occasionally when I'm printing too close to the glass or when I have filament that's particularly harder or needs higher temps, I will still get skipping. I've had to raise the filament temperature on a couple of rolls to get rid of that skipping, at least on the lower or first layers of the print. Now that's obviously a different experience than I had with the stock board. The stock board doesn't ever skip. Those A4988 drivers are workhorses and they have lots of power. So just take that into consideration. So what are you getting for your $55 to $80, whatever this board ends up costing you? Well, as we saw with the quality test, you're getting a quiet print experience. So who's this going to be worth that to? Well, obviously if you have this in a work environment, if you have this in a home environment, that silence is going to be worth a lot because now your printer is no longer being an obtrusive part of your life and it can sit over there and just do its job. So I think that that's who it's going to appeal to most. If you're looking for a print experience that has more features, that maybe has silence but with the strength of the A4988s or something similar for that extruder driver, then you're going to look for something different here. And in a few weeks, I'm going to have some more options for replacing this. Now, bottom line, this is still the easiest way to get a silence set up, because all you're doing is a drop-in exchange of the board, and as we found out, then maybe a little bit of tweaking to the voltages to get it to print just right. But that's about as easy as it's going to come. If you want to keep this stock display on here, if you like the touchscreen it came with, I think this is still going to be your best option. Now, if you're looking for a board with more features, or maybe you are looking to replace your display, there are other options from other vendors. You can get a board from TH3D, and as I'm going to show in a few weeks, you can also get a board from Big Tree Tech, companies like that. So keep in mind that while this is going to be the simplest and easiest options for some, there are more robust options for others. As I mentioned before, if you are looking to purchase one of these silent boards, check out Creality's official website. You know there you'll be buying directly from the source. You have the option of the correct firmware to be installed. And I think you're going to have an overall better experience than if you buy from a third party. And of course, that link is in my description as always. Now, before you run off, I have one more thing I want to show you before you click over to that next video. If you are into swag from YouTube channels, I've got some I need to give away. Obviously, with all that's going on in the world, I've got swag left over that I can't give away like I normally would at the various conventions like MRF and possibly even ERF. So for my new Patreons this month, if you subscribe at the $10 a month level or above, I'm going to be sending you these new sticker and magnet combo. These guys, this bumper sticker, got a holographic sticker, and we have a magnet that I'm currently sporting on these guys as well as my truck. They do stick to these metal boxes. So if you're interested, again, if you like this kind of thing, if you have a use for it, please check out my Patreon. I will, of course, show icons and logos here, and there will be links in the description. Go join at the $10 a month level. Again, if you only want to join for 1 month, you'll get the stickers, you'll get the stuff, and then you're good to go. So I appreciate all the support I get from you guys. I appreciate you watching this video. I hope I didn't run too long here. Again, there was way more here than just a drop in and go sort of mod. So that's what I showed you. Again, thanks for watching. I'm Chris. This has been Kersey Fabrications. Thanks for watching.